Hey guys, welcome to Leet Programmer. Today, let's look at the problem longest consecutive sequence. So, in this problem, we have a given array and we have to find a consecutive sequence which is the longest. So, in this example, we can see if we arrange this given list in ascending order, we get 1, 2, 3, 400, 200. Now, if you see the consecutive sequence, this is one consecutive sequence, this is a sequence, this is a sequence. Which one is the longest? It's this of size 4. So there you go. This is all about the longest consecutive sequence. Now, how do we solve this? One way is, as I just mentioned, what if we just arrange this array in ascending order? If we do that, then we can see how many how many sequences are present. So if we start iterating from here, we see 1, 2, 3, 4. That's a sequence. So we have 4. 4 plus 1 is not 5, so we have a new sequence which is starting. So we have 100. 100 plus 1 is not 200, so that's a new sequence. So the sequence length here is 1. We have 200 here. And the same logic follows. The sequence is 1, so the max is 4. Now, the runtime of this algorithm would be big O of log n into n. The reason being, the sorting algorithm used to go from this particular step to this step would be n log n. So, can we do better? Let's see. If we analyze this further, we see that we have 3 sequences, right? We have 1, 2, 3, 4. We have 100 and we have 200. Something common to notice here is this one does not have any preceding number, which means the number 0 is not present in this array. The same thing here. The number 99 is not present in this array. Same here. 199 is not present. So this is a common pattern that we notice. The start of a subsequence is denoted or is assumed by the fact that the preceding number does not exist in our array. So that's one thing to note. Now let's see. Now we start here. We see 100. We ask ourselves, do we see 99 in this array? We don't. That means 100 is a start of a subsequence. Awesome. So now we know that the sequence starts at 100. Now we have to see how long the sequence is. That is, we have to see, is there 101? We clearly see there is no 101 in this given array. So we know that the sequence size over here is 1. Now we encounter 4. We ask ourselves, do we see 3? We do see 3, which means that 4 is not start of a subsequence. We can ignore it and move forward. 200. Do we see 199? We don't. That means 200 is a start of the subsequence. Moving on. Do we see 201? We don't. That means the sequence ends here and the length of the sequence is 1. Now we encounter 1. We ask ourselves, do we see 0 in the array? Clearly, there is no 0 present, which means 1 is the start of a subsequence. Then we continue asking, do we have 2 in our array? Yes, we do. So the length variable is now updated to 2. Then we ask ourselves, now do we have 3? Yes, we do. So we again update the length variable to 3. Well, that's good. Do we have 4? Yes, we do. Again, the length variable becomes 4. Do we have 5? No, we don't. Since we don't have 5, we end there and we see that the length of our subsequence becomes 4 here. And we can essentially have a max variable which is updated each time. And we see that the max of this is 4. And that's our answer. Now, what would the time complexity of this algorithm be? Again, you might be wondering, searching for element in an array will take linear time each, and that gives us a disastrous runtime. But there's a trick that we are going to use. What if we convert this array to a set or a hash map? Well, creating a set or a hash map would take linear time, and accessing elements or checking whether an element exists in that set or hash map would also take a constant amount of time. This is what we want. Now, if accessing the element or checking if the element exists takes constant amount of time, then it's pretty clear. We go through the array once, and that's a linear time complexity. You might be wondering, but at each stage, we are probably going through an array. So at 100, we are trying to navigate through the array. At 200, we are trying to navigate through the array. At 1, we literally go through the array. Then why is it linear? One thing to notice is at 100, we do nothing. So that's good. At 4, we do nothing. That's good. At 200, we do nothing. By do nothing, I mean we don't navigate through the array, right? We just do some checks, which is a big O of 1, which is a constant time complexity. Now we come at 1. At this stage, we go and we keep checking if the next element exists, and we keep going. So we go to 1, 2, 3, 4, right? And so in the worst case, we might go until n, right? We might the entire array might contain consecutive elements, and we might just go throughout the array there, right? So we might just go n times there, right? And then we have 3 and 2, which is again constant. So here in this case, it can be argued that n is for going through the entire array here, and we also went through the entire array in the worst case in this step, which is another n, which is big O of 2n, which is nothing but the big O of n. So that's how we got a linear time complexity over here. Now let's get to writing some code. If you recall, the first step was to convert our given array to a hash map or set. In my case, I'm gonna use a set because it's literally one line in Python. Next, let's go through the array. So now, if you recall, we had to check if the preceding number exists. So if we had 1, we have to check does 0 exist. If it does not exist, that means it's the start of a sequence. So that's the case we are looking at. So if num minus 1 is not in our set, then we know that that's the beginning. And since we know that num is essentially the beginning of our sequence, we want to keep checking how many elements are there in that sequence or how many consecutive elements are there in that sequence. So we keep checking the next number. So we also have like a temp variable. Let's name it length and let's initialize it to 1. The reason we are initializing it to 1 is because the number itself is a sequence, right? So the length of that is 1. So if we have only 100, the length of the sequence would be 1. So here we have a while loop and we go till the number plus length is in our set. So if number plus 1, number plus 2, and so on is there in our set, we keep going. And here we just update our length variable. So each time it'll be, so first time it'll be number plus 1 because length is 1. In the next time it'll be number plus 2 and so on till the consecutive sequence exists. And after the while loop is over, or maybe even after the if loop, we can essentially update our max sequence length, where my max sequence length would essentially be maximum length of our sequence. Let's just initialize it to 0. It'll be the maximum of itself and length, the length variable here. We could also write it inside the if statement here, but we can also write it outside. That will be fine. And essentially at the end, we just want to return this maximum sequence length. And that's the solution. I hope you enjoyed this video. Please like, subscribe. See you soon.